What is the importance of including chemical analysis of both water and soil, and what does this analysis reveal that petrography and mineralogy cannot? Do these chemical tests identify actual concentrations of soluble salts, cations, and anions that affect plant health and soil structure, and how do they provide real-time evidence of ongoing acidicity processes? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How many groundwater and surface water samples were collected, and from which locations? What does the selection of 21 groundwater samples from wells and 1 surface water sample from a dam imply about the dominant sources of water in the region, and how might their chemical composition differ depending on depth, usage, and proximity to agricultural or natural landscapes? Why was the surface water sample included? Was it expected to show different chemical characteristics due to evaporation, runoff, or stagnant conditions compared to deeper groundwater sources? And does its inclusion help evaluate the full hydrological cycle in terms of salinity dynamics? What are the specific physico-chemical parameters measured in situ at each sampling point, and why are these variables, such as pH, electrical conductivity, EC, temperature, T, dissolved oxygen, DO, alkalinity, and oxidation reduction potential, ORP, crucial in understanding the salinity and acidicity levels in the hydrological system? How does pH influence the solubility of minerals and the mobility of sodium ions in both soil and water? Does a higher or lower pH promote the release or retention of salts? And how does this condition affect plant growth and nutrient availability? What does electrical conductivity reveal about the total concentration of dissolved salts, and how is EC used as a direct indicator of water salinity? How do high EC values correlate with plant stress, osmotic pressure, and the degradation of soil structure? Why is temperature important to measure during sampling? Does it influence evaporation rates, chemical reactions, or biological activity, and how does it interact with salinity levels, particularly in arid environments like Tierra Nueva where heat drives moisture loss and salt accumulation? What role does dissolved oxygen play in groundwater chemistry? Can it indicate aerobic versus anaerobic conditions, influence redox-sensitive mineral stability, or affect microbial processes that contribute to changes in water chemistry and soil structure? Why is alkalinity measured in this context? Does it reflect the buffering capacity of water to resist changes in pH, and how is this related to the presence of carbonates and bicarbonates, which may interact with sodium ions and influence precipitation or dissolution processes?